Hello students, welcome back. Today we will learn about the difference between enantiomers and diastereomers. Let us take an example of propane 2-ol CH3 CH CH3 and OH group present at the second position 1, 2, 3. So it is known as propane 2-ol. If we draw the Fischer projection of this molecule, let us see. We can see that if we arrange the HOH, the methyl group, and when we pass it through a mirror, in front of the mirror, if it forms its mirror image, HOH CH3 CH3. Here we can see the H and OH part is reversed and the mirror image is formed. So it is an enantiomer. Enantiomer. We will discuss this in detail. Here I have taken 3 molecules. These 3 molecules are interrelated to each other somehow. We will see each of it one by one. Here we can see the molecule, the upside and the downside position. It is covered with the methyl group, and the H is on the right side, OH is on the left, and it can be said it is in cis form. Now I have changed it into the trans form, but we can see if we place the mirror also, it does it produce a mirror image. So we have to see whether it produces a mirror image or not. But it does not produce a mirror image. We will see. If we will put a mirror here in the middle, if we put a mirror here, we can see the H and OH part will be the same. The upper part of the molecule will be showing the mirror image, but the lower portion is same, so it won't be showing. If we reciprocate it into this, if we impose it, the mirror image is not formed. The OH will be it should have been, the H should have been here and the OH should have been here, then it could have been easily superimposed. And the third group we can see, if we put this molecule in front of the mirror, it will surely form a mirror image. Why? Because OH will be put here, H will be put here, and the same will be for the lower portion of this molecule. The H will be put here and the OH will be put here. So these 3 molecules have certain kind of relations. So let's see between the first and 2. 1 and 2 are non-mirror images. Non-mirror images. Hence they are diastereoisomers. Because first and second molecule does not form any mirror image, so it will be coming under the category of diastereomers. Now we will see the relation between second and third. Here we can see, if we directly put the second molecule on the third molecule, it is not superimposable. So they both are non-superimposable. Although the first and second is also not superimposable, but they don't form the mirror image. But though it is non-superimposable, it does form mirror image. Hence it will come under enantiomers. Now we should also see the relation between first and third molecule. If we will see the relation between first and third molecule, we can see that they also form the diastereomers. If we will see, the mirror image is not formed, so it will be forming non-mirror image. So it will also come under the category of diastereoisomers. So in general, the enantiomers are non-superimposable and mirror image forming stereoisomers. If we look at the properties of this, the two enantiomers differ in which they rotate the plane polarized light. Like, it can rotate in clockwise or it can rotate in anti-clockwise direction, and they may possess different rates of reaction with other optically inactive compounds. If there is optically active or inactive compounds, their rates of reaction of these isomers, the enantiomers, are also different. Now if we talk about diastereomers in general, they both are also non-superimposable, but they do not form non-mirror image. If we look at this, although they form the mirror image, we can see no, they can't form the mirror image. Here we can see, if we rotate the upper portion, it does not form the mirror image, while the lower portion does show the mirror form, but while the upper part does not show the mirror form. So the entire molecule shows non-mirror image compound. So they differ in physical properties, like the density of D-tartaric acid and mesotartaric acid may be different. The melting point may be different, the solubility, the density, the dielectric constant, even also the specific rotation of the molecule will be different. Although the chemical properties may be similar of this compound with the other optically active when they react with other optically active compounds, but here the rates of reaction are different in enantiomers, but in diastereomers they form similar rate of reaction with other optically active compounds. If you do like the video, share and subscribe it. Thank you.